My name's Astrid, as you can see from that slide. I am a chartered environmentalist, and I am one of the few that was given their chartered status for their work in technology. And part of that was working with Deborah on circular economy, and then also marrying that with energy efficiency. And that's kind of what we need to do when we're talking about product life extension for hardware. Deborah mentioned that product life extension is kind of where it's at in terms of circular economy at the moment. Basically, by extending our product life, we are buying recycling time. We are buying recycling technologies time to recover all the materials that we need to recover from the amalgams and the coatings, etc. And we are also buying ourselves time to find a use for those recovered materials in new servers. So there are Innovate UK competitions open at the moment for recycling, but nothing for using the recovered materials. So that's why product life extension is really where it's at the minute. So this is a little bit of my life history. When I was growing up, my stepfather had 2 cars parked outside. One of them was dead and one of them was not dead. And he used the dead one to harvest component parts for his one that he was trying to keep on the road. He was a mechanic, and that's how my generation was brought up, to think of equipment as mechanics and as tools that we can use to deliver what we need to deliver. Technology is a tool. It's something that we should control, and we should understand that. And I shout quite loudly about this. I've not got a tech background. My one message is open the black box on tech. Find out how it works, take control of it, understand it, and make it work for you. So my stepdad did this, whenever he needed to, outside for years. This is a server. This is a server that has got fewer moving parts than a car. Deborah's been working on increasing the modularity in design. The fans are non-compatible between generations, makes and models. That can do with some work. But there are components there that are quite easy to take out and to slot into new machines. There are limitations on what you can do with that. So there's a limitation on which CPUs will fit with which make and model. And that's to do with technology change. So there's kind of stuff that you need to be aware of on that. The fans are Deborah's bugbear. There's no reason why we have to have all those different makes and models of fans. We could do better there. Power supplies are the first things to fail. You just swap them out. CPUs, I've mentioned. Memory slots, they're fairly interchangeable as well. It's not on here, but hard disk drives, fairly interchangeable. But the reason that people are reluctant to do that with machines, servers, is they say, well, what about Moore's law? What are we doing? Because each generation will be twice as efficient as the previous generation. I don't think that that's an assumption that people in this room will make, but it is an assumption that people make in the enterprise data center sector, because they don't look at the servers. They don't look at what they're doing. So one of the things that we were trying to do is address that, because we spent more time than is healthy looking at introducing circular economy into our own company. We're a refurbishment company. We spend a lot of time finding the best recyclers to take the equipment that we can't repair, so that we're trying to promote the development of bioleaching or chemical recovery or something that's high-value recycling. So we wanted to articulate that and make it possible for other people to do that with servers. So we needed to address the energy side of things. And we carried out a 2-year project to do just that, looking at performance, energy efficiency as a measurement of performance over energy draw for refurbished equipment, for new equipment, and what the difference was between them. This slide shows you the balance of where the components are in terms of energy draw and what's the most important. And as you can see, CPUs are usually responsible for about 65% of the energy draw of a server. So we wanted to pull things apart and rebuild them. And we did that in a controlled environment. But before we did that in a controlled environment, we checked what the CPU trends were telling us. So these are the most energy expensive items in a server, and you look at CPU trends, and you can see that the orange line is the performance over power at maximum load. That's no longer doubling in performance with every successive generation. And you look at the blue line, which is where it's spending time in active idle, that's actually getting less efficient over time. This is specifically for the core technology. So, at the moment, this is what's happening with the current servers that are available to the market. It may well change over time with AMD coming out with its new design. This is where we are at the moment with refurbishment. So we looked at those CPU trends and we thought, well, if we're seeing this, what can we do with machines to make sure that we're not losing massively on the energy draw when we extend product life? So Deborah's slide articulated that it's about a 50-50 environmental impact between use and embodied for newer servers. But the energy impact is about 80-20. So how do we redress that balance and make it viable to extend product life? So what we did was we got a load of servers in a lab, we put a power draw analyzer on them, and first of all we tested new versus refurbished. And we found that like for like there's really no difference. IT doesn't degrade over time, it either works or it doesn't. So once we'd established that, we started messing around with configurations. And we started looking at what the difference between energy efficiency was at the base, previous generation, immediate past generation, and the current generation. I would stress here that these are enterprise servers. We don't know what it looks like for OCP, but we would love to find out. That's a piece of work that we'll be hopefully working on soon. So when you do the base configuration against the base configuration, you realise that there's a 13% increase of efficiency between the latest generation and the previous generation. Not a doubling, by the way, and that latest generation is going to cost you 3 to 4 times as much than the immediate past generation. But there you go. When you faff around with it in low-cost ways and you upgrade the CPU to a higher performance CPU and you double the RAM, you realise that your immediate past generation can outperform the base version of the latest generation by 36%. Now, obviously, if you soup up that latest generation server, it's going to outperform the previous generation server, but this is a lot lower cost and lower impact, potentially, solution than pulling out your entire server estate and replacing them with the latest generation. What we're saying here is it really makes sense to think about upgrades in a data center, because it doesn't just make sense on the materials side, it also makes sense on the performance and efficiency side. Okay. So, if all that is true, why is it that we're seeing less than 20% of servers recycled or refurbished, which means an 80% waste in our server estates? Admittedly, there might be, that might be a higher figure because we just don't know, but we're seeing a significant amount of waste. And I think that the reason for that is more to do with the ecosystem than technical possibilities. So if you're going to try and transfer our mechanics into something that looks more like an ecosystem, you have to have effective resource pathways. So these 2 or 3 tier supply chains, very difficult to reverse engineer that and take it back to just the manufacturer. It's going to be very, very hard to do that. So you're going to have to find a way around that. We're going to have to share resources. We're going to have to share metrics. We're going to have to share methodologies. We're going to have to share ability to ship. We're going to have to become materials processors, where we hand things to the next user rather than just trying to take it all back to source and then rebuild from there. We need to improve our recycling at the end of life. And we need parity for prosumers, John's term, to make decisions, make sensible decisions about what do I want to do? How do I want to build my estates? How do I want to build my machines? And I would argue that where we are at the moment is that broken tree. We've got disjointed hardware. We've got, open hardware, which is not comparable with enterprise hardware because there aren't the metrics to compare them and because there's not enough discussion. We've got broken reverse logistics if we rely on the original manufacturers, just because they're so large and it's so difficult to get them back in. So we need to have an ecosystem where you have a marketplace where things are traded, which is what the secondary market is. But we need to find a place for that coexists with the primary market, and so that it's a symbiotic relationship and not this competitive, destructive relationship, which is what we've got at the moment. We've got massive lack of recovery, as Deborah's articulated. We've got compatible software as well. So, one of the reasons we can't just like-for-like swap in and out OCP servers is because they run on different software. So I would like us to get to that tree that works. And I think that relies on cooperation, sharing knowledge, ability to realise that you don't have to be in competition all the time. If we're in competition all the time, we're going to use our resources and then it's going to break. So we need to find a different way of working and we need to do it quite quickly. Is that an impossible dream? Because I often talk about very depressing subjects. Well, I would argue that maybe not, because we have a secondary car market that coexists with the primary car market. It might not be perfect. You've got lease, you've got dealerships, you've got people who are just operating with multiple makes and models of cars, and it is working to an extent. So why can't we do the same thing with the modern mechanics, which is our server estate and our IT hardware? Thank you.